Okay, guys, today we're going to learn 3-1 to 3-3. Although that may be shocking to you, don't even stress it because it's very, very simple. What we're going to be talking about today are inequalities, okay? And inequalities work just like equations, except that there's an inequality symbol. So what are these inequality symbols that I'm talking about? Well, you have less than, which is less than. You can have less than or equal to, and less than or equal to is the less than sign, but it has a line underneath because it can also be equal to that. Then you have greater than, okay, and greater than, just like that. And then you can also have greater than or equal to. And the greater than or equal to, very similar to the less than or equal to, is the greater than sign with a line underneath representing that it could be greater than or equal to it. Okay? Now, the difference between an inequality and an equation is that in an equation you have one set final answer. In an inequality, you can have an infinite number of answers. Now, what am I talking about? Let's see the difference. Let's say I have x plus 3 equals 7, but then let's say I have x plus 3 is greater than 7. The good news, every procedure for solving equations is exactly the same as solving inequalities. The only difference is when you're multiplying or dividing by a negative. And we'll get to that in a second. But right now, we don't have to cancel these out with multiplication or division. It's simple subtraction. So I subtract 3 to both sides, and x equals 4. That's it. X equals one number, and only one number. Okay? But in this one over here, subtract 3 to both sides, x is greater than 4. Now, what does that mean? What does that mean? That means that the x values that are greater than 4, not equal to 4, 4 does not count here, but the values that are greater than 4 will make this equation true every single time. So how can we test to see if we're correct? Let's prove to you that 4 is not a solution. If I do say that x is 4, okay, I'm going to have 4 plus 3. Okay, is 7 greater than 7? Is great that I don't want to know what all the other things you guys just said. Please answer the question. Is 7 greater than 7? No. So is 4 a solution to this? That's why you got to pay attention. 4 has to be greater, x has to be greater than 4. So let's prove it. Let's say x is 7. Let's see if that works. 7 plus 3 is greater than 7. Is 10 greater than 7? Yes, so it works. So that's how you can test and find out to see whether or not a solution works in an inequality. So in this particular case, guys, since we're dealing with many, many solutions, you can do a graph. You can represent the solution with a graph, okay? For example, I'll teach you how it works right now, but let me just show you a visual. Let me just show you a visual. In this particular case, let's see here. All right. In this particular case, let's shrink this up a little bit. All right. I'm saying that x is greater than 4. I'm going to show you how and why I did this in a second, but just watch. Greater than or less than, I'm going to use an open circle. And I am saying that x is greater than 4. So to which direction am I going to shade? To the right, because everything to the right of 4 is greater than 4. And that would be your graphical solution. So that's what we're dealing with today, okay? Now I'm going to go into some intricacies of how this all works. Okay? Okay, so let's go ahead and talk about how I created this graph, and let's talk a little bit more about testing whether or not a given value is a solution to an inequality. When we're dealing with graphing inequalities, this is very, very important, okay? A lot of people have been trained incorrectly on how to read an inequality in the first place. And in order to read an inequality, please remember, you read from the variable. I don't care if the variable's on the left side or on the right side. You read from the variable. From the variable. Okay, guys? I'm not trying to be sarcastic. I just want you to really understand this. You read from the variable. So let's practice a little bit. Okay, from the variable, how would you read that? X is less than negative 4. Awesome. From the variable, how would you read this? Okay, we just had a 4 is, and that's not correct. It's from the variable. X is greater than 4. Very good. From the variable, guys. What is that one? From the variable. X is greater than or equal to negative 3. Great. From the variable. X is greater than or equal to negative 8. From the variable. And I'm going a little bit advanced, but I want to make sure that you guys got this. We can have a compound inequality. We'll talk about that later in more detail, I promise. But just in case you see this, and just to really make sure that you understand how to read an inequality, how do you guys think you would read this one? Remember, we're reading from the variable, and you have two inequalities, so that means you have a compound inequality. I mean, there's two inequalities going on here. Yes, sir. Very good, son. That's the way to do this. Awesome. Great job. What he said was this, guys. This is really two different inequalities. This is x is greater than negative 3, and x is less than 8. That makes sense, boys? So we read from the variable. You may be thinking, yeah, Mr. Moore, you titled this as graphing inequalities. Why are we talking about reading? Because if we can't read, we can't graph. Yes, sir. You are jumping the gun, but that is exactly as where we're going right now. Thank you, my brother. May I continue? Okay. Now, what my boy was jumping the gun about is where I was going right now, which is fine. When I'm graphing, guys, if you're given a greater than or a less than, you're going to use an open circle. Period. There's no ifs, ands, or buts about it. If you are given a greater than or equal to or a less than or equal to, you're going to use a shaded circle. No ifs, ands, or buts about it. There's no choices on this. This is just the way it works. Does that make sense? All right, this is just the way it works. So if I have a greater than or less than, I have an open circle. If I have a greater than or equal to or a less than or equal to, I have a shaded circle. Well done. Now, let's practice a couple graphs. And then we'll go from there. Let me throw up some graphs here. Let's go ahead and clone some of these guys. It's like magic. Okay, for this first one, gentlemen, let's go ahead and let's graph it in red so you can really see what's going on here. Okay, I'm not even going to read it out loud because I'm going to give it away. I want to see if you guys know how to read this. Okay, who's got this? Yes, sir. My boy said x is greater than or equal to -4. First part is correct. You read it correctly. Now, what do I do? Very good. X is greater than or equal to -4. So that means -4 is a solution. So it's solid. That's why it's solid, by the way, guys. Because that means that it is included in the solution. When it's an open circle, that means it is not included in the solution. Okay, so I've got my closed included solution on -4. What do I do now, my brother? You're going to go to the right. That's exactly correct because x is greater than. So you make a nice little arrow. Please do not do this. This is done by a lot of people in middle school. I don't know why. I don't like it. So please do not do. A lot of people will do this. They'll go above the line, and then they'll go like this. That's awesome, but I'm going to mark that wrong. Please do not do that because that doesn't even make sense. It's not even on the line. I know that you guys are in pencil, so it's kind of hard to see a line on top of a pencil. So actually shade it. Okay? Shade it. I'm not going to make you write all these numbers. All I'm going to expect is the following. You got to put your 0 always. Always. So all I'm asking for, to pay attention, got to put arrows on both sides. And then just put your -4. Closed circle, shaded to the right, big arrow, and that's fine. Is that fair? All I'm asking for is the 0 and then the number, the location. Okay? You do not have to put all the other numbers in between. I'm trying to make this easy for you. I want you to understand the concept. Okay? Now, if it's a fraction, you're going to have to do it a little bit differently. We'll do a fraction in the next one so I can show you. Does everyone understand so far, though? Okay. Why don't we do this to give myself some more space? Why don't I do this? Let's bring this guy here, and this guy here, and this guy. All right. Thank you. Sorry about that. Let me give you an example with a fraction so you can see what I'm talking about. Let's say I tell you x is less than, I shouldn't have said it. Oh well. X is less than or equal to 2/5, okay? Pay attention. It's the only time you're going to have to write numbers. You have to in this case. Make your little line, put your 0. Okay. 2/5 is between what and what? Between 0 and 1, correct? So whenever you have a fraction, you first got to find out what two numbers is it between. So it's between 0 and 1. So make your life easy. 1/5, 2/5. Boom. I got to see that. Now, is this going to be an open or closed circle? Closed circle because it's less than or equal to. Am I going to go to the left or to the right? To the left because it's a less than or equal to. Does that make sense, my brothers? You promise? Awesome. Okay. How would you do this? Any volunteers? Oh, I saw your hand up first. Let's go, Sil. Oh, come on up, man. Do it. Let's go. For those of you out in the internet world who's watching this, if this is wrong, it's not me. It's one of my students. No, I'm not going to say his name. That's I only say it if it's right. And he is correct. Very good job, my brother. Awesome. Sil, good job. All right. Now, does that make sense, guys? Okay, let's do another one. What if I say to you, how about this one? Let's go. Do it. Come on, man. Let's go. Let's go. Get on this. It's right there, my man. First, read it. Read it for us. Okay, why are you reading from the number? No. X is greater than or equal to 4. Yes, sir. Please pay attention. You always read from the variable. Solid circle because it's greater than or equal to. That is perfect. It's greater than, so it goes to the right. Okay, be careful. You made 3 mistakes there in a row. But hopefully you learned it. Okay? Good job. I know you were nervous. No worries, my brother. Okay? Let's do one more, guys, and then we're going to add on a new skill. Okay? Go for it, son. Go for it. Read it for me. What is it? How does that read? X is less than negative 2. Fantastic. Fantastic, son. Open circle on the negative 2 because it's less than. It is not included. Awesome. And then X is less than. Yes. To the left. Very good. Think about it. Less than, it's going to the left, correct? Good job. Okay. Here's the question. If it's easier for us to just switch this, okay, no. That is going to be harder for you. And this is why. How many people, just be honest with me, okay? I'm trying to help you because this is a common mistake. If you wanted to switch this, how many people think it would be like this? Okay, I have a hand up. Thank you for your honesty. That's the danger of flipping it, sir. That is wrong. If you're going to do that, you got to keep the signs the same. So you still got to go X is less than negative 2. Okay? That's fine. If you want to switch from this to this, that's okay. But I'm really highly suggesting against it. Because I'm telling you, you're going to be on a quiz. You're going to be on a test. You're going to be on a time crunch. You're going to be nervous. You're going to say, oh, I don't like it like that. Okay, it's greater than negative 2. And then it's all wrong. I'm not making fun of you guys, but I'm telling you what happens. This is what happens on tests. Instead of trying to find a way around my lecture, can you guys please just listen to the lecture? I don't see what the benefit is of turning it from this way to that way when it's the same exact thing. I don't see the benefit. I see a loss of time, and I see a potential for mistakes. So, with all due respect, why can't we just learn how to read it? X is less than negative 2. When you go to the left, you're going less than. When you go to the right, you're going greater than. So this is X is less than negative 2. Open circle on the negative 2 and go to the left. So again, if you want to switch it to this, that's fine. I will not mark that wrong. However, if you switch it and you switch it the wrong way, that is your problem. And I have warned you about the danger of that. I do not suggest for you to do that, but I cannot control your actions. Is that fair? Okay, thank you guys. Now, that's pretty much 3-1. Learning how to graph it, knowing what an inequality is, all that good stuff. Now, oh wait, last thing for 3-1. I apologize. This is very important. Sometimes they're going to give you something like this, gentlemen. They're going to say for the inequality, 2x plus 1 is greater than negative 3. Okay? They'll say something like this. Which value is a solution? And they'll give you something like negative 3, negative 1, let's say 5, and let's say 0. They want you to replace the x value with these and see if it's a true statement or not. So we are evaluating, plugging in. So this is 2 times negative 3 plus 1 is greater than negative 3. This is negative 6 plus 1. That's going to be negative, I'm sorry, that's a 3. Negative 5. Is negative 5 greater than negative 3? No. Remember that the larger the negative, the smaller the value. So this is a big fat no. No. Let's try negative 1. 2 times negative 1 plus 1 is greater than negative 3. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Is negative 1 greater than negative 3? Yes, so that is a solution. How about 5? We got 2 times 5 plus 1 is greater than negative 3. Is 11 greater than negative 3? Awesome. Yes. Then when x is 0, 2 times 0 plus 1 is 1. Is 1 greater than negative 3? Yes. So it's very similar to plugging in solutions for an equation. You're just looking for a true statement. Yes, sir, and then yes, sir.
Can you just find x and then see if it's
Okay. You amaze me with that question. Yes. I just didn't want to get too far advanced. The question was, Mr. Morrow, can't you just solve that equation and know which one of these will work? Yes. But this is 3-1, so they're assuming that you haven't learned how to do this yet, but you're awesome. This is just like an equation, correct, guys? So what my boy just finished saying was, Mr. Morrow, to save time, can't we just solve this like a two-step equation? And that's what I'm doing right now. And the answer is abso-freaking-lutely. Anything greater than negative 2 is a solution. So think about it. Is negative 3 greater than negative 2? So that's not a solution. Is negative 1 greater than negative 2? Yes, so it's a solution. Is 5 greater than negative 2? Yes, so it's a solution. Is 0 greater than negative 2? Yes, it's a solution. And I don't know if you noticed, but did any procedure of solving a two-step equation change for solving this? No. Like I said, we're going to learn now in a few minutes the only time that it changes. Sir? Which value or values? I apologize. Next. Okay, I apologize that I didn't say values, guys. I apologize very sincerely. Let's use a little bit of logic. Mr. Morrow's choosing more than one value. I guess there's a few values. I apologize sincerely. Does that make sense, gentlemen? Okay. Now, let's talk about solving inequalities using addition, subtraction, and then multiplication and division. Okay, we're going to solve one-step inequalities today. That's what we're going to be doing. Luckily, there are no differences at all when you're solving inequalities using addition or subtraction. Like, I mean, none. Okay? So this is 3-2 already. And you solve inequalities exactly the same as equations, comma, except x, and maybe I should learn how to spell, except when you multiply or divide by a negative. Not to a negative, but by a negative. And we're going to get to that in a little bit. Right now, we're just going to be solving using one-step equations using addition and subtraction. So if we're just dealing with addition and subtraction, there's nothing to change. You solve multi-step equations just the same as you solve multi-step inequalities. The only difference is when you multiply or divide by a negative, you flip the inequality sign. Okay? And I didn't even put that. When you multiply or divide by a negative, comma, you must flip the inequality sign. Not if it's negative, the inequality sign. So if it's greater than, you make it less than, etc., etc. We'll get into that though in a second. Right now though, let's go to Mickey Mouse land. Okay, bless you. For example, they'll just go ahead and say solve and graph. They're going to ask you to graph a lot. Sometimes they won't ask you to graph, then you don't have to. But if I say solve and graph, you have to graph to get the full credit, gentlemen. So x minus 15 is greater than negative 12. Guys, this is exactly like an equation. In fact, when I was a kid, I just used to pretend that was an equal sign. Because it used to stress me out. And I was like, oh my God. But no. Chill. Pretend it's an equal sign. How do we get the x alone here, brothers? No, you don't bring a negative 15. You add 15 to both sides because you want to cancel that out. Thank you, son, for participating. Negative 15 plus 15 is 0. X is greater than 3. 0. Here's my 3. Open circle. I'm going to the right because x is greater than 3. Did you guys just see that? How awesome that is? If you know how to solve equations, this is a joke. If you know how to add and subtract and multiply and divide integers, fractions, and decimals, this is almost exactly like chapter 2, except with the little inequality sign, and you got to do a graph. Sir. Okay, no worries. Does that make sense, my brothers? Pretty simple, right? Okay. How about this one? Example. M minus 11 is greater than or equal to negative 2. How do we cancel out that negative 11? How do we get that M alone? Heck yeah, you add 11 to both sides. M is greater than or equal to 9. My arrows, my 0, at least one number there, a 9. It's greater than or equal to, so I'm talking about a solid circle, and I'm shading to the right. Does that make sense, gentlemen? Okay. I could do it the other way, too. What have I said to you? X minus 3/5 is less than 2/3. Okay? What do we do here? There's a couple different strategies to solving this. I'm very proud of you, son. That's a great strategy. A lot of people that don't like working with fractions like to get rid of the denominators like we've taught, and that is fantastic. I can go ahead and multiply both sides by 15. And then I distribute, and that's going to be 15x minus, what's 15 times 3? 45. 45 divided by 5 is 9. And then you got to multiply 15 over here. What's 15 times 2? 30 divided by 3? 10. Then you add 9 to both sides. 15x is less than 19. Divide by 15. Right? And x is less than 1 4/15. Now, some people, for whatever reason, don't like doing that. They don't enjoy that process. So that's fine. X minus 3/5 is less than 2/3. What's another way to do this? Yes, sir. That's exactly right. Thank you, son. You're going to get x alone, so you add 3/5 to both sides. Now, x is going to be less than, what are the common denominators here? 15, right? So doesn't that go to a 15, and then that goes to a 10? And doesn't that go to a 15, and that go to a 9? Then you add the numerators, keep the denominator the same, so that'd be 19/15, which still equals 1 4/15. Now to graph this, okay? This is good. This is a good practice for graphing. I did divide it, son. 15 goes into 19 one time, and there's 4 15s left over. I turn that into a mixed number. If I wanted to go to a decimal, which I did not ask for a decimal, I would not do that because you're going to make your life more complicated. Leave it as a fraction unless you are told to do otherwise. Okay, now, this is going to be 0. What is 1 and 4 15ths between? 1 and 2. So you got to at least go like this for me. 1 and 2. Okay? And then this is going to be 1 and 1 15ths, 1 and 2 15ths, 1 and 3 15ths, and 1 and 4 15ths. So this is going to be an open circle. Am I going to go to the left or to the right? X is less than 1 and 4 15ths. So I'm going to the left. Does that make sense, gentlemen? Yes, sir. I'm not going to make you do that. If it was 1 and 13 over 15ths, I would accept this. I'm not a monster. I would accept it as long as you use a little bit of logic, okay? 1 and 13 15ths is a lot closer to 2, correct? I would accept this. I would have accepted that. Now, if you put that 1 and 13 fifths over here, I'm not accepting it. Does that make sense? Because that location does not make sense there. Does that make sense? Sir?
If you add the 1 on the side, it's already a 1.
Yeah, okay, I see what you're saying. Yeah, if you just want to put the 13th, 15th, that's fine. Thank you, Pablo. What he asks is, can I do this? And put the 13 15ths here? Yeah, technically you can because it's 1 and 13 15ths. Yes, sir. Yes, if we're going to go through that logic, yes, we can go ahead and reevaluate this. So this is 0, here's 1, here's 2. Is it closer to the 1 or closer to the 2, closer to the middle? Yeah, it's closer to the middle, so I would like, not exactly the middle, but I'd put it like about right here. Is that fair? Is that fair, my brothers? Okay. Does that make sense? Awesome. All right. Let us continue then. Let us continue then to 3, 3. All right. Yeah, multiplying and dividing. Now, here's the key here, guys. Whenever you're multiplying or dividing by a negative, not to a negative, but by a negative, you got to flip the inequality sign. Let me show you the difference between multiplying to a negative and by a negative. 3x is less than negative 9. I'm dividing 3 to both sides to cancel out the x. Did I divide by a negative? So I do not flip the sign. I divided by a positive 3. Now let's look at it the other way. Let's leave that negative 9 there. That's not the one that changes anything. That's why I'm going to leave it the same. This time, what am I dividing by? I'm dividing by a negative 3. Do you see the difference of dividing to a negative 3, which was example 1, and dividing by a negative 3, which is example 2? Now that I divided by a negative 2, I flip the inequality. So this graph here for number 1, 0, negative 3, open circle to the left, less than. This one over here, the graph for number 2, 0, 3, open circle, greater than. Whenever I divide by a negative, that's when I flip it. When I divide by a negative. Or when I multiply by a negative. For example, now I'm going to be showing you in example 3, multiplying to a negative, which does not change the sign. X over 3 is less than or equal to negative 2. Here I'm going to multiply both sides by the reciprocal, just like the regular equations. That's why we can do a lot today. X is less than or equal to negative 6. Did I multiply by a negative 3? I multiplied by a 3, right? Positive. So I do not flip the sign. And this graph here, 0 is negative 6, less than or equal to, solid circle, and to the left. Does that make sense? Then number 4. Yes.
Negative
Excuse me.
3x, but we're like dividing by it, and we already like flipped the sign.
Don't, again, you're trying to go your own shortcut way. Follow the steps and do it in order, please. This is what he asked. If I see a negative 3, can I just switch it immediately? This is what's going to happen to most people if you do that. You're going to go negative 3, you're going to switch it, right? Then you're going to divide by negative 3, and 90% of the time you're going to reflip it. Because you're going to say, oh yeah, I divided by a negative, so I got to flip it. So again, sir, can you do what you just said? Yes, technically, yes. I strongly am against that, though. Do not do that. Do not do that. Flip it after you have multiplied or divided by the negative. It's not that much work, guys. Now, let me show you what happens when you multiply by a negative. Again, I'm going to keep that negative to the same because it does not matter. What matters is what you're multiplying or dividing by, not what you're multiplying or dividing to. So in this case, I'm going to multiply by negative 3 over 1, the reciprocal, negative 3 over 1. Did I multiply by a negative this time? So now I flip the sign, and that's going to be x is greater than or equal to 6. So a small little graph here. Here's 0. Here's 6. Greater than or equal to, closed, filled in circle, and to the right. Does that make sense, guys? Yes, sir. I never said flip when you change the sign. Is that at all what I've been repeating 100 times today? You flip the inequality when you multiply or divide by a negative. I don't know what you mean by change the sign. That doesn't make sense to me. You can have, for example, 5. Negative 3x is less than 12. I divided by a negative 3. X is greater than negative 4. Why? Because I divided by a negative 3. I don't care about the sign of this one. This does not affect the inequality. What affects it is what I multiplied or divided by. That's why I have been saying by, not to. Okay? If you multiply or divide by a negative, you flip the inequality. And then this graph would be negative 4, open circle, greater than, to the right. Thank you so much for your honesty. Does that make sense, gentlemen? Please, I don't want you to go home and do them all backwards. Does that make sense, gentlemen? Okay, now, another skill that is really good. Sometimes they'll tell you to write an inequality from a graph. So check this out. Let's do these a little bit nicer so you could see. Oh, that's not what I wanted. Okay. That's nice, but that's not what I wanted. This is what I wanted. Okay. All right, for example, gentlemen, what if I gave you the following? Who can tell me what that inequality is? Sir.
Negative 4.
Okay, why are you going from the number when I have said at least 15 times today that you always read from the variable? Sir, x is greater than negative 4. Fantastic. Open circle, that means it's going to be greater than or less than. From the negative 4, am I not going to the right? So that means that x is greater than negative 4. Okay, does that make sense, guys?
Yes, sir.
Okay, what if I told you this? What if I say this? Who can tell me the inequality there? Sir,
X is less than or equal to
x is less than or equal to 4. Fantastic. Solid circle around the 4 means it's going to be either a less than or equal to or a greater than or equal to because it's solid. And it's going to the left. So that means that all of the x values are less than or equal to 4. Perfect. That makes sense, my brothers. Awesome. Great class. God bless you. Have a great day.